Alright, in this video we're going to take a look at some more examples of solving exponential equations. So in example 1 part C here, we have 9 times 3 to the x power equals 7 to the 2x power. Now notice that on the left hand side, the 9 times 3 to the x, we can rewrite 9 as 3 to the second power, so that both of our expressions on the left are written as a base of 3. So we can write this as 3 to the second power times 3 to the x equals 7 to the 2x power, and then using our product property for exponents, 3 to the second power times 3 to the x power is 3 to the 2 plus x power. So we have 3 to the 2 plus x power equals 7 to the 2x. Now we can take the logarithm of both sides, and I'm just going to take log base 3 of both sides since, I usually go with the smaller value anyway. So we have log base 3 of 3 to the 2 plus x power equals log base 3 of 7 to the 2x power. Now again, we could shortcut our work by knowing that log base 3 of 3 to the 2 plus x power is just going to end up being 2 plus x. But if we forget that, we can use our power rule to bring the 2 plus x down and get 2 plus x times log base 3 of 3, and then log base 3 of 3 is 1. So we're going to get 2 plus x times 1 is just 2 plus x. But again, we can avoid this extra step in the middle here by knowing log base 3 of 3 to the 2 plus x power is 2 plus x. Likewise, we can use the 2x with log base 3 of 7 to the 2x. We can bring that 2x down using our power property and get 2x times log base 3 of 7, which we can't really do anything with right now. So we have 2x times log base 3 of 7 on the right-hand side. Bringing our x terms over to the right-hand side by subtracting x from both sides, we get 2 equals, when we subtract x from both sides, I'm just going to write the negative x first because there's a lot going on in this expression. Instead of 2x times log base 3 of 7 minus x, I'm going to write this as negative x plus 2 times x times log base 3 of 7. So just as a way to put the variables first. Now both these terms, the negative x and the 2x log base 3 of 7, have an x in them, so we can factor that x out. And on the right hand side, we're going to get x times negative 1 plus 2 log base 3 of 7. So x times this expression, as crazy as it looks, this negative 1 plus 2 log base 3 of 7, it is a real number. It's a crazy decimal real number, but it's still a real number. So since we're multiplying x by this real number, we can just divide both sides by that negative 1 plus 2 log base 3 of 7. And when we do that and we put it into our calculator, we get about 0.7866. Now again, you can check that that is correct, because recall that if you put in the original problem, the left side of the original problem on your calculator, and then the right side of the original problem on your calculator, the solution will be where the graphs intersect, what the x-coordinate is of the intersection point for the graphs of 9 times 3 to the x and 7 to the 2x power. They are going to intersect when x is about 0.7866. So you can use your graphing calculator to check that. All right, part D, we have 75 equals 100 over 1 plus 3 to the negative, or 3e rather, to the negative 2t power. So I don't like working with fractions any more than the next person. So if you multiply both sides by your denominator of 1 plus 3 times e to the negative 2t, it'll eliminate the fraction. So we get 75 times 1 plus 1 plus 3e to the negative 2t equals 100. Dividing both sides by 75, we get 1 plus 3e to the negative 2t equals 100 over 75 reduces to 4/3. So we still want to get this e to the negative 2t by itself. We got a 1 we're adding and a 3 we're multiplying. So if we subtract the 1 from both sides, we're going to get 3e to the negative 2t equals 4/3 minus 1 is 1/3. Then dividing both sides by 3 or multiplying both sides by 1/3, we're going to get e to the negative 2t equals 1/3 times 1/3 is 1/9, or 1/3 divided by 3, same as 1/3 times 1/3 is 1/9. So now we have an exponential expression alone. We can take, in this case, we're going to take the natural log of both sides, because the base of the exponent is e. The base of the natural logarithm is also e. So we get the natural log of e to the negative 2t equals the natural log of 1/9. Copying that over to the next slide because I'm running out of room here. If we want, we can use our power property to bring the negative 2t down, and negative 2t times the natural log of e, and then the natural log of e is 1. However, a shortcut would be, since we have the natural log base e of e to the negative 2t, that expression on the left side is just going to simplify to negative 2t, so you can skip this middle step. So we have negative 2 times t equals the natural log of 1/9. Divide both sides by negative 2, and when you type this in your calculator, you get t is approximately 1.099. So again, if we graph the original problem's left-hand side and graph the original problem's right-hand side, we will see that they intersect at a value of x value of about 1.099. All right, that about does it for this video. Thanks for watching. I'll see you next time.